Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Engineering. So, in continuous with the previous session, here I am going to discuss about the population inversion, pumping methods, characteristics of laser, differences between ordinary and laser light source. The first one is the population inversion. So why we are going for population inversion here? So we know that working principle of laser is stimulated emission. So this stimulated emission can be achieved by the population inversion. So we should know about the population inversion. So population is nothing but the more number of atoms. So here that mentions the more number of atoms. Usually the atoms will be more in the ground state only, but population inversion means the atom should be more in the excited state, then only we can have a stimulated emission. So for that process the atom should be in the excited state or more. So this is represented by N2 greater than N1. So N2 is nothing but number of atoms in the excited state. N1 is the number of atoms in the ground state. So this is the pictorial representation of the population inversion. So for first picture shows the normal population. So in normal population we know that all the atoms wants to be stay in the ground state only. So here more number of atoms present in the ground state. In second picture, that is inverted population. So that is here the more number of atoms present in the excited state. So to have the stimulated emission we need to achieve this population inversion. So then how we can achieve this population inversion? Let's see. That is called the pumping methods. So the process of rising the atoms from ground state to excited state by means of artificial, that is called the pumping process. Here we have different methods of pumping actions. We have different methods, that is optical pumping. Optical pumping means we can use a light source for exciting the photons. Second one is the electrical discharge method. Here the atoms can be excited by the electrons. And third one is the direct conversion. So in direct conversions, one energy then can be converted into another energy. Fourth one is inelastic collision between atoms. Here the two atoms can be involved for this pumping process. And finally chemical process. So due to some chemical reactions we can achieve the population inversion. So first one is optical pumping. Here the atoms will absorb the energy from the light source and then moves to the excited states. So this type of optical pumping can be used in the solid type of laser. So example here is NdOC laser. So example for optical pumping is a xenon flash lamp and krypton flash lamp. So that we can use the flash lamp for the optical pumping. This is the electrical discharge method. Here the atom is first induced by the electrons. So that is represented by the equation A plus E. A is the atom and that is induced by the electron and that moves to the excited states. So the star, A star indicates the atoms present in the excited state, and after that the electron will come back to the ground state. So this type of pumping method can be used in the gaseous laser. So example is carbon dioxide laser. Third one is the direct conversion. So this type of pumping used in the semiconductor lasers. So here the electrical energy can be converted into light energy. So example is gallium arsenide. So fourth one is inelastic atom-atom collision. So the atom-atom mentions the two atoms. Here we are taking A and B. So the first atom can be excited by the electron and that moves to the excited state, and that excited atom will induce the another atom. So that is the B star. So now B star will be in the excited state. So example is helium neon laser. So helium is one atom and neon is the another atom. Both should have a same energy level. Chemical laser. So in this we have some chemical reactions to excite the atoms from the ground state to excited state. So example is dye laser. Characteristics of a laser, so that will have a unique characteristics. So because of that characteristics only they have a different applications, main applications in industrial and medical field. So that features are highly directional, highly intensity, and that is the monochromatic source and high coherence. So these are the four important characteristics. And directionality. So first one is the directionality. So it mentions it can travel for a long distance with a less divergence. So we can compare with the ordinary light. The ordinary light have a larger diversion, but the laser have a small divergence angle, and that can travel for a long distance. The next one is brightness or intensity. So the laser light concentrated on a small area, that we know that will shows like a point. So that will concentrate on a small area. So the intensity would be more. And monochromatic, that we know that this is based on the material, and this will have a single wavelength and a single frequency and less spreading. So that's why it is comes under the monochromatic source. And coherence. So coherence, we know that the photons are wave packets. So every wave packets or every photon will have the same phase, direction and frequency. So that's why we are telling they are coherent. So if we see difference between ordinary and laser light source means we can have a difference with these characteristics: directionality, intensity and monochromatic and coherent. So directionality, laser can travel for a long distance, but the ordinary light source doesn't have. And intensity is more in laser compared to the ordinary light source. And a laser is a monochromatic, but ordinary light source is a chromatic. And laser is a coherence and ordinary light source is a incoherent. So this is the difference we can see. So next, this will be continued in the next session. Thank you.